It sounds crazy, but one factory can implant more than 5,000 hair strands every minute into plastic doll heads. You're not imagining it. That's faster than a sewing machine. And the faces? For hours, the hollow eyes watch nothing, waiting for paint to turn plastic into something that almost feels alive. When the brush finally moves, every stroke decides whether it looks gentle or haunted. So how does a plastic shell end up looking back at you? Today, Captain Discovery steps inside the Halloween doll factory to find out. Long before factories and plastic, dolls were carved from wood or shaped from cloth, made to comfort, not to frighten. In 19th century Europe, porcelain faces and glass eyes made them prized possessions. But when those eyes cracked or turned cloudy, people started whispering stories about souls trapped inside. By the mid-1900s, America gave dolls a new identity. They became movie props, symbols of innocence turned strange. Films like Child's Play and Annabelle turned playthings into nightmares, and collectors began chasing limited editions that blurred the line between art and fear. Today, Halloween dolls follow that same legacy. Some are made to look broken, others to look too real, each one balancing nostalgia with unease. What began as a child's toy has become a seasonal tradition that celebrates the beauty of being just a little bit unsettling. Production starts with PVC pellets, tiny white grains stored in silos that each hold up to 2 tons. From there, vacuum tubes feed the pellets into large hoppers connected to injection machines. Inside, the material is heated to around 200 degrees Celsius until it melts into a thick, clear liquid. Precision pumps push the molten PVC through nozzles into hardened steel molds chilled to a constant 15 degrees Celsius. Each mold contains multiple cavities that shape the doll's head, arms, torso, or legs. The plastic flows under high pressure, filling every detail, from tiny dimples to joint sockets. After just a few seconds, compressed air cools the shell from the inside, forming lightweight hollow parts that make the doll easier to pose and cheaper to ship. When the molds open, robotic extractors lift out the pieces and place them on conveyors. Cameras scan each one for bubbles, seams, or thin walls. Any part outside tolerance automatically drops into a scrap bin and is remelted for reuse. This closed recycling loop saves nearly 8% of material per production run. Before painting, trimming machines use rotating blades to remove excess plastic from the mold gates. Dust collectors vacuum the edges clean, and the pieces line up for the next step, where hair, paint, and expression will turn blank shells into lifelike figures. Each blank head now moves toward a row of machines that work like mechanical tailors. Instead of glue, steel needles punch strands of nylon hair directly into the vinyl scalp, more than 5,000 insertions every minute. Each one pierces, loops, and locks the strand from inside. The fibers are dyed in heated drums, then cooled, brushed, and wound into tight spools. As the machines feed them through, a faint static hum fills the air, the sound of lifeless heads slowly growing hair. Once implanted, the strands are trimmed and shaped by robotic combs. Heat lamps curl or straighten them into style. From a distance, the conveyor seems calm, until you realize every head has a different expression. Some look peaceful. Others, by accident or design, don't. Did you know every doll's hair is stitched, not glued? Hit like if that surprised you. This is where the dolls begin to look back. Robotic arms spray a fine layer of primer across each head, followed by soft tones of skin pigment. The air smells faintly of solvent and heat. Digital printers then move in, printing lips, cheeks, and eyebrows in perfect alignment. Every pass adds color by microns until the expression appears. Finally come the eyes. Twin laser-guided heads print both at once, layering iris, pupil, and reflection in exact symmetry. Even a 0.2 millimeter slip can turn calm into fear, or kindness into something colder. Once the ink cures under ultraviolet light, the heads roll forward for inspection. Thousands of faces glide past the cameras, identical in design, yet somehow, no two seem to look away. Different body molds arrive from separate lines and queue for assembly. Robotic arms pick up each torso and align it with its matching limbs. Pneumatic pistons press the parts together with controlled torque, locking the sockets while preserving smooth motion. Every joint is tested by automated shakers that flex arms and legs 20 times to ensure balance and durability. Next comes the dressing line, a long conveyor where textile precision meets automation. Pre-stitched outfits arrive from nearby sewing units in stacked trays. Workers guide delicate fabrics onto mannequins while robotic grippers pull sleeves and close Velcro tabs. Tiny accessories like belts, earrings, or handbags drop from feeders and attach magnetically to avoid scratching the paint. At the quality station, motion sensors check that clothing doesn't restrict movement. Each doll is also weighed to verify that no component is missing. Once cleared, the finished figures pass under bright LED lights for a visual review of color and symmetry. At a glance, it's just production: plastic, fabric, and sequence. But under the white factory light, the assembled dolls seem to multiply, row after row of silent faces waiting for eyes to open again. Automated arms place the dolls into transparent cases, adjusting the posture to face the window perfectly. Thousands of boxes glide down the conveyor toward waiting trucks. From above, it looks like a single, endless stair moving toward the exit. By nightfall, pallets are loaded and shipped to stores around the world. Within days, these silent faces will appear on Halloween shelves, smiling, perfect, and waiting to be chosen. If dolls capture the human form, the next Halloween icon captures something far darker, and it melts before the night is over. It's hard to believe, but troll dolls were once banned in American schools. According to Smithsonian Magazine, students thought these toys brought bad luck.
It's Wish Day!
Still, factories kept molding them, millions at a time. By the end of the 1960s, the so-called cursed dolls became one of America's best-selling toys. So what made these odd little figures explode in popularity? Let's take a closer look inside the factory that made fear profitable. The troll doll began in Denmark in 1959 when woodcarver Thomas Dam made one for his daughter's birthday. Local demand grew so fast he replaced hand tools with aluminum molds. By 1963, U.S. importers were ordering by the container. Some schools banned them for bad luck, but sales didn't slow down. In the 90s, neon colors and glitter hair brought the dolls back again. From superstition to pop culture, the troll doll became a strange yet lasting icon. The process starts deep in the molding hall, where drums filled with powdered vinyl are rolled into position. Workers attach them to feeding lines that carry the material toward massive rotary molds. Once sealed, the molds begin spinning at speeds close to 1,000 rotations per minute. Heating elements inside each chamber melt the resin, forcing it to spread outward from centrifugal force. Every rotation coats the inner surface evenly, layer by layer, until a soft shell takes shape. Cooling water at 15 degrees Celsius hardens the body within minutes, creating a flexible shell with that signature rubbery bounce. The figures then tumble through rotating drums filled with soft pellets to smooth away rough spots. Robotic sprayers apply thin layers of primer and skin tone pigment using electrostatic charge so every curve is evenly coated. Infrared heaters dry the paint without melting the vinyl, leaving a soft matte texture that looks warm and natural under store lighting. Nearby, rolls of polyester fiber are dyed in heated drums spinning at 400 RPM. The strands are rinsed, dried by 70 degrees Celsius air jets, and combed straight by high-speed rollers that remove tangles and static. Cutters trim them to about 6 inches long before grouping arms twist each bundle into a small plastic plug. Pneumatic pistons press these plugs through pre-molded holes on the head, locking the hair in place. Steam nozzles then blast warm vapor to make the fibers flare upward, forming the troll's unmistakable flame-shaped hairstyle. For special editions, extra dye sprayers add colored tips for that gradient, rainbow look. Inkjet printers draw every eye, brow, and smile with UV curable ink that hardens instantly under light. Robotic pickers attach miniature gems, belts, or skirts with glue thinner than a strand of hair. Sensors and cameras scan each face, catching any shift of more than a millimeter. Then, vibration platforms shake trays of dolls to test adhesion. Any loose part goes back for rework. It's a precise balance of art and automation, giving every troll its bright eyes and eternally mischievous grin. They look harmless, but every pair of eyes is printed to the exact same stare. Creepy or cool? Comment what you think. Before shipping, dolls are pulled, twisted, and scanned to meet ASTM and EN71 safety standards. Once cleared, robotic arms seal them into clear blister packs and group them into cartons. Each box carries batch numbers for traceability before wrapping machines close them for export. From molten vinyl to packaged toy, one production line can craft more than 80,000 troll dolls a day, all identical, yet somehow each with its own spark of mischief. Back to the living room floor, where millions of kids race tiny cars across the carpet. Since 1968, more than 6 billion Hot Wheels have been produced. more than every real car on Earth combined. Each one starts as molten metal, molded in seconds, painted, and tested by laser for perfect balance. It's real engineering, just small enough to fit in your hand. Here's how the world's most collected car is built. Hot Wheels began in 1968 when Mattel co-founder Elliott Handler wanted toy cars that actually moved fast. He teamed up with designer Harry Bentley Bradley to create the first 16 models. Lightweight zinc alloy and plastic wheels made them faster than anything else on the shelf. Their bright metallic paint and orange tracks changed the toy market overnight. By the 1970s, Hot Wheels became a symbol of speed, color, and design. More than 50 years later, the formula still works: precision, motion, and a touch of nostalgia. In the die casting section, furnaces heat a blend of zinc and aluminum alloy beyond 650 degrees Celsius until it moves like liquid mercury. The molten metal is injected into precision molds at pressures over 1,500 pounds per square inch. Each two-part cavity forms a miniature car body in less than a second. Hydraulic arms open the molds, and cooling fans blow air to freeze the metal instantly. Ejector pins push the solid shells onto steel conveyors, still warm to the touch. Robotic trimmers glide along the edges, shaving off thin flashes of excess metal. These leftover ribbons fall through chutes into collection bins. They're melted again and reintroduced into the furnace, keeping material waste below 2%. A single casting line can produce more than 1,000 car shells every hour. The cast shells tumble into massive rotary barrels lined with fine ceramic beads. As the drums spin, friction smooths every contour and erases micro-scratches left from molding. The process runs for 10 to 15 minutes depending on model size. When finished, the polished shells emerge with a satin metallic sheen. Next comes the cleaning tunnel. Jets of deionized water blast away dust and residue. Hot air dries the parts before they reach the paint booths. Here, a closed-circuit ventilation system ensures no overspray escapes into the air. Charged sprayers apply a primer, followed by a thin metallic paint, and finish with a transparent clear coat. Each coat is applied by robotic arms moving in pre-programmed arcs, synchronized to the conveyor speed. Infrared heaters raise booth temperature to around 70 degrees Celsius to harden the finish without warping the metal. Down the line, plastic chassis pieces molded in another facility arrive by conveyor. Robotic arms align each base under its matching metal shell. A pneumatic press snaps both sections together using a precision-fit locking system. The bond is tight enough to withstand pressure without glue or screws. Next, axles made of hardened steel slide into pre-drilled holes. Rotating arms fit the wheels onto each end, locking them with microscopic clips. Each axle spins on a small ball bearing to reduce friction. That's why Hot Wheels roll faster than most toy cars. A testing ramp sits right beside the assembly zone. Each car rolls down a smooth, angled track equipped with motion sensors. Computers record rolling distance, acceleration, and deviation in speed. Cars that stop too early or drift sideways are pulled off the line. Rejected pieces are stripped for parts and recycled. In one 8-hour shift, a single line can assemble up to 50,000 cars. Precision is everything. A difference of half a millimeter could affect how straight a car runs on its track. That's why automated gauges measure axle alignment every 5 minutes. When tolerances exceed limits, machines recalibrate automatically. With the cars assembled, it's time to give each one its unique look. Pad printing machines press silicone rollers over ink plates filled with colors and logos. The pads roll gently over the car's curved surfaces, transferring stripes, flames, and numbers in layers. Each color cures instantly under UV lamps before the next layer is applied. High-resolution cameras capture every finished car and compare the pattern against a digital template accurate to 0.1 millimeter. In a separate bay, special edition cars receive additional touches: chrome rims, translucent windows, or glow-in-the-dark paint. These limited runs are produced in smaller batches, often less than 1% of total output. Which Hot Wheels model did you race the most as a kid? Tell us in the comments. At the final stage, mechanical arms pick up each finished car and slide it into transparent blister packs. A printed cardboard backing drops underneath, showing the model name and artwork. Heat sealing presses bond plastic to paper with short bursts of pressure and warmth. Every pack passes across precision scales that detect missing or extra parts by weight difference. Packing robots then group 72 units into shipping boxes. Each box is sealed, labeled, and scanned for tracking before moving on to automated pallets. Stacking robots load them into trailers bound for regional warehouses. From there, shipments travel to distribution centers across the globe, from California to Singapore. Quality teams randomly open boxes at the end of each run. They test wheel spin, paint durability, and blister strength to ensure cars arrive in perfect condition. Even temperature changes during transit are monitored, since extreme heat can loosen the plastic shell. In total, the process from molten alloy to packaged car takes less than 20 minutes. A combination of speed, automation, and precision makes it one of the fastest toy production lines in the world. And that's why a $2 toy can roll like a real machine. From soft vinyl to molten metal, every product we've seen today started as raw material and ended as a piece of childhood memory. Dolls built with machines that mimic human touch. Trolls molded from superstition and turned into global icons. And cars so small yet engineered with the same precision as the real ones on the highway. Each factory line reveals how design, chemistry, and automation work together to shape imagination into something you can hold. Behind every smile, every color, and every wheel lies a system measured down to the millisecond. It's not just nostalgia, it's industrial art. If you enjoy discovering how everyday icons come to life, don't miss what's coming next. Hit subscribe, stay curious, and join us again as Captain Discovery steps inside another factory where wonder begins.